Well, now we move on to the next session, that is the second masterclass, Understanding the Building Blocks of Blockchain Technology. And we have a very senior executive from IBM to take us through the fascinating subject that would become an essential part of our business soon. May I please invite Mr. Jitan Chandanani, IBM Blockchain Services. Can we have a huge round of applause for him?
First of all, of course, a very warm thank you to the sponsors as well as to IIGC for this opportunity. A quick introduction. Of course, my name is Jitan Chandanani. I manage the blockchain business for IBM for India, South Asia. Very glad to actually be here. I'm just going to wait for the presentation to come up. But in the meantime, I think what I actually want to do on today's agenda, it's a very simple presentation. First, let's just talk about what you call blockchain and what I call blockchain, because I think it's been quite the buzzword for the last 2 years. And just to make sure, I'm pretty sure everybody in the room has heard about blockchain, Bitcoin at some time or the other, right? Yes? Perfect. Okay. Could we have the presentation up? Okay, let's start with the other presentation. So I think what you want to do right on top is, what is blockchain? And of course, there's a whole fancy technical definition, but let's just park that fancy technical definition. Let's actually take a step back. And since a lot of you actually deal or are some ways part of the industry, we all keep hearing some simple words, right? And the one simple word which we keep hearing is a transaction. And if you think about it, what is a transaction? Technically, a transaction is not an exchange of money. Perfect. What is a transaction? And I would say a transaction is not an exchange of money, because if I give you a bottle of water and you give me a bottle of Coke, that's a transaction. And there was no money that exchanged hands. So a transaction technically is an exchange of assets, right? And money is just a settlement mechanism. That's what typically a transaction is. Let's think of a transaction that probably goes beyond just a simple bottle of water and Coke, right? I think something that we all may probably be familiar with is like buying and selling a house. So let's assume these different tables are different parties that actually are part of this transaction. I am a buyer. The table over here is the seller, and I actually want to buy their house. What do? I give them an offer. The seller actually reviews the offer. But you know what? The seller can't really just sell the apartment or sell the actual property, right? He needs to get some kind of approvals from a society who has to give some kind of certification. Then there's a government that's actually involved, which needs to give me some stamp duty registration. There's a bank involved, which basically gives to give me a loan. Suddenly, this one transaction has 5 parties involved: buyer, seller, society, government, and the bank. What do you call these 5 parties? We call them an ecosystem. Technically, if I actually go down to the jewelry store and I buy a bullion or I buy a gold biscuit, is that the ecosystem? Not really. What is the source of that gold biscuit? The miner, the supply, the logistics people that actually went in, the certification authorities, the government, the stamp duties that kind of went into, those are a part of the entire ecosystem of gold. And every transaction today is done by an ecosystem. Let's go back again to the house transaction. The deal actually happened, okay? I bought the house. What did I go home with? I went home with this really nice fat binder. That binder had about 60 documents. It had the stamp duty papers, the registration papers, the NOC papers, the government papers, the society papers, and everything else. What did the seller go home with? The same fat binder. What did the bank go home with? The bank has this fancy operating system or banking system, and they basically added one line in the operating system that, you know what, Jitan owes them a loan of X lakhs. What did the government do? Same thing. They made a change in the ownership in their systems. What did the society do? They have this Excel documentation where they change some ownership rights, right? Now the question happens that every transaction requires an ecosystem. And at every end of a transaction, everybody keeps a record of the transaction. In what? In something that they call the word ledger, or the word books and records. My ledger is my binder. Your ledger is Excel. The bank's ledger is SAP, Oracle, or whatever the fancy systems actually are. Today, every transaction is recorded in the world in some kind of a ledger. and 40% of transactions result in disputes. If all of us were party to a transaction, all of us agreed to the details of a transaction, why is there 40% disputes? Because all of us use a different version of the ledger. Simple. And all of us stored the information like I understood it. For me, the fact that the society gave approval was good enough. But for the government, it was not, because it didn't meet the regulatory requirements. For the bank, some paperwork was not enough. For the seller, it was actually enough. As a result, multiple ledgers result in disputes, and that's actually the reality of things, right? Why is blockchains a big buzzword? Blockchains are a big buzzword because blockchains attack this fundamental of the word ledger. Blockchains are not about Bitcoin, and we'll come to that. But blockchains, in the most simplistic sense, are all about ledgers. A ledger is fundamental to any transaction, be it trading options and derivatives, as we just spoke about, be it in supply chain financing, be it in a house sale, be it IBM selling cloud services. Everybody records a transaction in a ledger, and blockchains became a buzzword because of the word ledger. Now let's talk about what exactly is a blockchain. I think I would expect most of you to remember how the old film strips used to look like, right? They were these massive black strips with like pictured boxes actually in of them, right? So think of it, I was actually making a movie. I make a movie scene by scene. Scene 1, the first picture. Scene 2, the first picture, and then the big black ribbon. What if I cut out scene number 23 and scene number 27? The movie stops making sense. Think of blockchains being a digital ledger on the cloud. Everybody has access to it who are party to an ecosystem. Take the same home seller example. I bought a house. I want to make an offer to a house. When I make an offer to a house, when the offer is actually made to the seller, the bank gets notified. Am I even qualified to get a loan? The society gets notified at the same time in real time. Is this seller right seller? Is this house can actually be sold? The government gets notified that, you know what, probably this is a selling has to be made. So a ledger that replicates the transaction in real time. A ledger that authenticates. Is the seller the actual true person who can sell the house? Is he really qualified? Am I really qualified for the loan? Blockchains are ledgers which replicate, which run business rules in real time. So you're actually running business executions in real time. In the cases of products and quantities, commodities, if I'm actually making an order for, let's say, 100 products, my value is 1 rupee a product, that's 100 rupees. But if I order 200 products, it's a 5% discount. If I order 300 products, it's a 10% discount. So can a ledger, at the time of execution, validate that, you know what, the order has been made, the price is X, these are the business rules. So blockchains are ledgers that replicate, run live business rules. At the same point of time, they maintain privacy. What's the relevance? I'm a bank. Do I care if the buyer and the seller are buying tomatoes, onions, or houses? Not really. The bank wants 4 things: debit, credit, name of buyer, name of seller. Do what the transaction be. That means that the transaction has got 20 different fields, the bank requires 4 fields. When all of us do transactions, every time we submit everything. Because, and this the best example that goes is, if when we were growing up and you actually went to a club, you were asked for a license, ID, right? You showed your entire birth date, showed everything on that particular license. All the bouncer asked was, were you above the age? But in today's ecosystems, we provide more information than we should. So blockchains enable privacy. So a ledger that replicates, runs business rules, maintains privacy. But the most important why blockchains are a buzzword is because it maintains consensus. Simple English, we all agree on one thing. But let's just take a transaction, right? I did 5 transactions that have 5 parties. Each transaction is 1 rupee each. The transaction got replicated. All the business logic was executed, privacy maintained. What should be the value in all the books? 5. So I go to the first party, I check the value. Value is 5. Second party, the value is 5. The third party, the value is 3. What happened? If all the transactions were done in real time, replicated in real time, then the value should have been 5 in the third party also. Either the third party is trying to commit a fraud or it's under attack. The network gets shut down or throws that party out of the transaction. The blockchain's inherent feature of consensus keeps all the parties who are participant to a transaction in sync at all times. As a result, no reconciliation, no disputes. 33% of cost savings for every single corporate can be achieved from the operations department. The average time it takes to settle disputes, be it any organization, is 21 days. I'm going to give you an IBM number. We work with about 4,000 plus vendors globally. And at any point of time, we had $100 million stuck in disputes. So we started using blockchain. Our number is gone to below 10 million, and our dispute time has gone to below 10 days. That's what was the power of blockchain. All it was very simple. It's a cloud-based ledger. Why the importance of cloud-based ledger is because the maturity of the participants is not relevant in terms of IT. Blockchains connect to SAPs. Blockchains connect to Excel. Blockchains connect to feature phones. Blockchains connect to smartphones. So I don't need every participant to be sophisticated, and that's the power of actually blockchains. Which is why I think what we are seeing increasingly is that the blockchains are actually spreading across industry. Be it supply chain, be it pharmaceuticals, be it mining, be it trading, all these industries are going to be impacted by blockchain in the next coming 5 years. And that's actually happening right now. But before we actually go down to how actually blockchain impacts the gold industry or what's the application, let's kind of also talk about the whole cryptocurrency and Bitcoin piece, right? Because I think there's a lot of contamination of what blockchains are and what Bitcoin is, and how do those two actually tie together. Now, the idea of cryptocurrency, first of all, nor is it new, and the idea of Bitcoin was actually very noble. The part about certain parts of the world yet being unbanked, the lack of transferability or scale usability of certain cash or certain currencies, were all problems we've all actually dealt with. Or simple as that, most of us have dealt with problems of high exchange rates when we actually travel abroad. That's a very common phenomenon that's always been existing. Also, the idea of using tokens or digital currency actually dates back to 1983. So Bitcoin was not revolutionary in terms of what the idea for digital currency was. That's a very old idea that actually came into place. But I think what probably, and I think you guys are the experts in this, need to understand that why even Bitcoin became a big feature, right? And for that, you need to kind of go back to the history of what fiat currency is and what actually gold is. You guys are the expert on gold, but I'll probably ask a question. The first very gold transaction that actually happened, who knew the value of gold at that point of time? What was the basis of that value? Well, the way our hypothesis is, somebody actually had a bag of potatoes, and this is all a hypothesis, and actually went to somebody else who had some rocks of gold and said, you know what, I'll exchange that bag of potatoes for those few rocks of gold. Because nobody knew whether gold was valuable at that point in time or not, right? The value of that bag of potatoes was equal to value of 2 goats. Those 2 goats were equal to 4 bags of rice. The first transaction of gold probably was actually a leap of faith. That's what we can safely assume, was probably a leap of faith. But the fact then goes back, why is today gold used as a medium of exchange? And for that, there are 118 elements in the chemical table. Why gold? Why just only gold? Why is gold so powerful? As we go through deduction, and if you think about the 118 elements, I cannot trade liquids, nor can I carry a liquid, because my pants are going to leak. I cannot carry gas in my pocket, because you know what? That I cannot. That's going to pretty much evaporate or something. Then, let's talk about some of the other metals, like iron. To make a coin of iron that's actually worth 100 rupees, the coin is going to be so heavy that I cannot even carry it. Titanium, platinum, the noble metals. The heating point of titanium and platinum is so high that to make a 100 rupee coin, you got to spend 150 rupees. Copper, silver, they actually corrode. There's actually a deduction mechanism why gold stands out. Gold is scarce. That's why gold is important. Gold doesn't corrode. Money cannot corrode. Your value of a rupee note is going to be worth 1 rupee any point of time. Currency cannot corrode. If this is gold, this in my hand belongs to me. If I give this to you, it belongs to you. A transaction in gold is anonymous. The idea that gold doesn't corrode, is scarce, transaction anonymous, and the best part, you can divide, add, subtract, multiply gold. That is what qualifies for a medium of exchange, and that is the power of what a fiat currency should look like. So gold, the qualities of gold were used to define a fiat currency. The qualities of a fiat currency were used to define Bitcoin. If I took all these 5 features and I actually made digital code which was scarce, there's only a finite number of Bitcoins in the world. Gold doesn't corrode. Bitcoin is digital code. Digital code doesn't corrode. Gold can be traded anonymously. Bitcoins can be traded anonymously. Gold can be added, subtracted, divided. Bitcoins can be subtracted, added, divided. So it met all the qualifications of a medium of exchange. And that's why Bitcoins became a value, a concept of cryptocurrency. But again, going back to the same idea, the first transaction, well, some developers got together and they distributed 10,000 Bitcoins, or whatever the number be, among each other. One fine day on May 21st, 22nd in 2010, somebody put up an article on Reddit. I want 2 pepperoni pizzas, and I'm going to give them 10,000 Bitcoins if anybody takes up the offer. Somebody did. That was the first Bitcoin transaction in the world. Suddenly, that piece of code actually had a value. That's how Bitcoins actually came into play. And from there on, the market actually grew. However, what is important to understand that Bitcoin and blockchain are 2 different things. And the best way to explain that is, let's use the concept of Gmail. What is Gmail? It's a type of an email. Email, it's a type of a message type, right? How does message type work? Gmail is a message type that follows a protocol. What's a protocol? I need a username and a password. What's the protocol for you to get the email? You need an email address. Gmail is a message type that follows a protocol that runs on the internet. Simple? Bitcoin is a message type that follows a protocol that runs on blockchain. Bitcoin is one use case of blockchain. If I remove this message type from a Bitcoin to an invoice or a supply chain financing, that becomes another use case. Bitcoin is just the most successful use cases of blockchain that came in play. However, now with the evolution of the technology, a lot more is actually happening on blockchain. And I think that's what I want to cover in the second part of my presentation. However, what's important to know, what cryptocurrency started out as a medium of exchange, that's not what it actually stayed on. They actually became a speculative item, which is why you have governments not actually supporting these cryptocurrencies or not accepting these cryptocurrencies. As a result, because they're not really backed by a particular asset, which is why cryptocurrencies may probably never be actually a great play, unless they are going to be issued by a central government. But the main idea is cryptocurrencies run on blockchain. And when you hear all these ideas about this blockchain, this Bitcoin got hacked, that Bitcoin got hacked, the blockchain got hacked, let's be very sure what got hacked. Bitcoin is a message type that has a protocol that runs on blockchain. The protocol got hacked. Much like if your Gmail gets hacked, it's your password that gets hacked, not the internet. Nobody can hack the internet. Much like nobody can hack a blockchain. People hack the protocol. So it's important to understand what the hacking, what the technology actually does. Okay. In terms of blockchain use cases that we actually felt were applicable to the overall mining industry across the board. Now, I think we as a firm have the luck or the visibility of actually working through industries across the board from end to end, right? And we've been actually looking at use cases which actually focus on exploration and mining. And the idea is very simple, right? If I am actually an exploration site and I've got about 30 or 40 different vendors working together, how do I trust that the information coming from all of them is accurate? What technologies can actually be used? Like if I actually just talk of the ecosystem of gold, there may probably be about 30 to 35 different players. Each of them using their own systems, each of them sending information in different formats, each of them with the ability to change information. Are you sure that tomorrow, if you have a piece of gold, you can track it to the last mile? You can tell me exactly where the handoff actually happened, where the exchange, probably in some cases you can actually do. But is that the industry standard? Well, that's not what our understanding of the current state is. And that's where blockchain use cases are coming out. Right from the starting of exploration, can you actually track a particular piece right from the source of the ore to the logistics pieces, to the filtration plants, to the certification authorities, to the government requirements, to the end jeweler, to the end seller? Blockchains actually provide you a digital ledger because if I can provide one ledger that works in the cloud, it enables every party to put the information in one place. At the same point of time, Bitcoin maintains privacy. What does that mean? I can be a logistics guy. I drive trucks. I have a jeweler for whom I drive a truck for basically 100 rupees. But for the other guy, I drive for 150. Privacy enables that two parties don't see what the transaction data are. You only see a transaction data because you're a part of it. And that's what makes blockchains much more secure than the current systems in play. Compliance and regulations. The average cost for compliance is about 9 to 13% in every organization. What is compliance? Paperwork, documentation, audit, risk assessments, that's what compliance is actually. You collect the data that's been used by your operations and execution groups, you arrange them in certain cuts so that you're ready to give it to the government. That's what compliance and regulations actually are. If all my transactions were available on one ledger, it's a simple download. That's why blockchains probably work much better. Trading, commercial, marketing, and supply chain. Again, we are actually working with use cases across the auto industry, across mining industry, trying to simplify your overall invoice processes. And take an example of GST, right, for those who are familiar with GST. GST is a very simple fundamental, right? On the 10th of every month, you submit the invoices. On the 15th, there's a break report. On the 20th, you submit the updated invoices. If I am even a mid-sized manufacturer, 100 crores, I probably about 100 to 500 suppliers. In 5 days, how am I expected to actually clear out these invoices? As a result, I'm leaving working capital on the table. If I actually had a blockchain which worked across my suppliers and across my vendors, which could track purchase order to delivery, to price corrections, to line rejections, and auto-generate invoices, we would all have the same invoice. Guys, this is not a dream we are selling. This is the reality which we are doing in some of the organizations, very much in India. In fact, I think India is slowly emerging one of the hottest bed for blockchains across insurance, across auto, across any aspect of lending, and actually across telecommunications. The hottest markets, actually. This is actually just a slide. What the slide we had was the overall ecosystem. What are the different parts and the exchange of hands that actually happen in a typical mining industry, irrespective of what the product lines actually are. If we actually put these parties on a chain, you would actually have an end block across any number of deliveries, across any scale of assets, which had all the main attributes of the particular transaction. However, being honest, the most difficult part of convincing people of blockchain is actually a cultural adoption. And partially, this cultural adoption has been contaminated because of Bitcoin. The idea that all blockchains are Bitcoin, I think, is what the first step actually has been. The second is like, people are very prone and very comfortable with old age processes. The idea of what this process can get you is the second step. When we have been working with organizations, and my most famous story is actually a Walmart story. And this is a true story available all over the internet. The Walmart CMO actually went to one of the Walmart stores and actually picked up a pack of mangoes. Came and threw it on the table in the conference room. True story. Asked his people, find out where these mangoes came from. It took the staff 6 days, 19 hours, and a few seconds to find out where the mangoes came from. Today I ask you the same question. If you actually have a couple of jewelry, how much longer it's going to take you to find out the source of that jewelry? So the staff actually went back, said, you know what, if I look at the Walmart ecosystem, it's got the farmer who grows the mangoes, it's got the village collection center, it's got the distributor, it's got the filtration plant, the cold storage plant, the logistics guy, the actual store owner, and the point of sale. IBM actually spoke to each one of them. What is your problem? Would you consider coming on blockchain? One said paperwork. One said lack of digital connectivity. The other said something else. But they connected all of them to blockchain. As a result, was born the Food Trust platform. Today, Walmart, Nestle, Unilever, Dole, all of them actually track food on blockchains right from food to fork. Could this apply to gold? I personally believe yes, it could. And I think that's where blockchains will actually play a big role. I'm not going to go through every single slide, but this slide, what I actually have on the screen, we identified 30 different players in a gold ecosystem. 30 pieces of information that's actually exchanged across. What is the cost of that information? If you actually went to every participant and provided them an efficiency point across this, the so-called ROI, we believe that was a convincing argument for actually a blockchain across the entire ecosystem. And that's actually what we are working with companies like RCS Global, who are, of course, very well known from an auditing standpoint as well as compliance standpoint. And the expectation is to work with, of course, different industry participants for the piece. The adoption of blockchain on day one is not going to be the entire ecosystem. Simple state, if you think of a process having 10 steps, what you'll start with is step 2 to 3, 7 to 8, or 9 to 10. And then the ecosystem will come. So the idea is not to think that I will actually get everybody on day one. The idea is to get a very small number of participants who can influence the actual market. Likewise, today, Bitcoin network is about 3 million nodes. It didn't start at 3 million. It started at 5. Today, it's 3 million in less than about 9 years. Same thing. The adoption of blockchain is imminent. You got to decide where you actually sit on it. What we actually have at the bottom part of the screen is actually the participants that we actually came up with. And the idea was if you actually use a mix of different technologies and actually connected the different piece of information, this would have completed. All of this could actually just work off one system, just one system. Who would bear the cost of that system? Who would actually run that system? And those are questions that you probably need to ask. And I think that's what you want to cover, complete things about the adoption approach. If the idea is that ecosystem participants all come together, okay, and they are trying to solve a systemic problem, then who should pay for it? Well, divide the cost. And the cost we keep talking about is like we actually are working with organizations, banks very much in India, who want to do trade finance. Why? Because trade finance is a transaction that involves banks. If all the 10 banks had the same operational problem, why don't we create one system and divide the cost? We talk about things like security. Let's be honest, all of us spend money on security. Is your security ever going to be as good as IBM? The answer is no. Will I ever be able to sell gold? The answer is no. I do what I do best. You do what you do best. Let's give the ownership of which person does the best. If the idea of a blockchain system is let the vendor, IT vendor manage the systems and you become the user of the systems. That's where blockchains are far more efficient than any other solution available in the world. The likes of SAP, Oracle, we've actually done analysis across those. Blockchains are far more cheaper and actually easily adoptable systems altogether. However, the adoption process is not that simple. You have to understand the most important part of blockchain is defining a right use case. IBM propaganda is 600 use cases all over the world. Not more than 20% are going to see production. It is very important to understand whether you can actually influence an ecosystem, whether you actually even need blockchain. I'll give you a classic example. Our friends of MCX are actually over here. NSC is actually over here. NSC does a fantastic job what it does. Do I really need to change that system on blockchain? The answer is no, because the current system works very well. NPCI, UPI, RTGS systems, fantastic systems. Where I'm trying to go with this is, if it's not broken, don't fix it. But there are enough ecosystems which actually require some kind of efficiency, some kind of transparency, and that's where blockchains will play a key role. And that's the first part of the exercise. Evaluate your use case correctly, identify your ecosystem, and ensure that you actually have the authority to influence the ecosystem. Walmart could influence the ecosystem, which is why the Food Trust Network was actually gone. If today I need a country-wise ecosystem, I would need a government to basically influence it. If I want to trade finance, the banks need to kind of work together. So that's the first step of business evaluation. And then I think the rest of the step. But the first step is what takes us pretty much the longest. Also need to understand what kind of blockchains you want to run. When we talk again about Bitcoin, they are public blockchains. I can join a Bitcoin network using a laptop. But I cannot join a trade finance blockchain because that's run by the banks in India. If you're not a bank, you don't participate. If you're IBM, you don't participate. Why? Because you're not a bank. That's what you call a private blockchain. In a private blockchain, the use case is defined by the participants. The membership is defined by the participants. It doesn't require 3 million nodes. It requires probably 50 or 75 participants. As a result, no problems with speed, no problems with scalability. And the last but not the least is where we have consortium blockchains, where companies are building one-type solutions, be a payment system, or be a particular remittance system. Generally, I think where you will actually land up being is in the private blockchain, where I think we expect most ecosystems to actually develop. How the overall stack actually works? Blockchains, if you kind of understand, are conceptually very simple. They work on the cloud. As a result, you will need to kind of get a cloud provider. Running a blockchain from your own data center, not really the best idea. The remaining pieces of blockchain are fabrics, again, which are open source, on which lies the business logic. The reason why this slide is actually important is when you're thinking of getting onto a blockchain solution, it's also important to understand how you're going to maintain and support it going forward. And I think those pieces are what people actually leave out when they're trying their first blockchain piece. But the main expectation is make sure you understand the use case, make sure you understand the ecosystem, and make sure you have a future plan as to how to support and maintain a chain altogether. Last but not the least, I think, of course, when you're looking around for a solution as to how long a blockchain solution will actually take, we've actually done pilots in, I think, about 3 months. And this is 3 months working with about 5 to 8 different corporates. Somebody who tells you it takes you 2 years to make a blockchain probably doesn't know what they're actually doing. And it's important to understand, out of this 3 months, you'll spend more than about a month at least just in the business case validation. The technology is easy, but the business case validation is the most important piece of the technology. And in terms of like the key cost factors that I think people keep asking us, blockchains, much like any other technology, it's like building a website. And I'll keep using it's a very bad example, but it's like a website. For a website, you need a hosting space. Where are you going to run the website from? You actually need business logic code. You actually need designs. You actually need UI. And there are some of these pieces which you keep paying month after month. Blockchain also is made up very similar component. You need cloud, which is where your blockchains actually run. You need somebody to actually code the business logic for you. That's a second cost. You need somebody to maintain it for you. Those are the additional costs. And then as participants keep adding on, you may probably have some additional costs going in. But it's important to understand which components are actually subscriptions and which are those fixed one-time costs when you're actually going. These are all part of a very detailed adoption approach that you need to kind of make sure they're running with the right partner to kind of build an overall solution. I think, again, we're going to leave this presentation, of course, with the rest of the group. There are multiple references across industries where I think we are actually working with blockchain. And the entire idea was just to let you know that this is pretty much a reality. And the expectation is that by 2025, there'll be at least more than about 20 to 25 different networks across industries running on blockchain. Sure.
Please carry on.
So the question is, how do you connect the transaction to the physical asset in the jewelry industry? Now, I'm actually going to take the example of the most famous blockchain, the oldest one. It's called Everledger. Everledger is a diamond blockchain. And the expectation was that, of course, because of conflict diamonds, how do you even source the asset going forward? Blockchain, as I said, simply put, is the word ledger. Okay? It actually tracks the information that you put in a particular asset. What blockchains do, if I actually have the mining, the expectation is that the miner actually puts in the amount of, I guess, the ore that's been extracted and what batches it actually fills in. The expectation is as that particular batch moves from source to source, each participant that touches it authenticates that, you know what, X quantity was received, this was the quality of the quantity, what certification was provided. It goes to the next step. Maybe the next step is a logistics person. Out of the batch number 1, it was distributed in 4 different areas. Who signed off on those 4 distribution areas? What was the quantity that was given off at the warehouse? What was the quantity that was received at the final location? At the final location, what further distribution or filtration was actually done? How do you connect the asset? You connect the asset by making sure that anybody who touches the asset, be it for certification, be it for processing, actually keeps a continuous chain ongoing. As a result, when the asset is finally ready for sale and you have authenticated validations of all the different life cycle events, you can pretty much trust what's the value of the end asset that comes out. That's how blockchains actually work. In the Everledger case, Everledger pretty much tracks every diamond right from the source to the cleaning suppliers, to the cleaning agents, to the apps certification agencies, to the end store that actually gets sold to every hand it exchanges. That's the ledger, that's a record that Everledger actually keeps. As a result, it's actually been building trust in the ecosystem that, you know what, the diamond that you're actually buying is actually a conflict-free diamond. And that's a real-time blockchain that's been on since 2015.
Thank you very much. Now I would request Mr. James Joes from CGI McLoys to present the memento to